So this is the last unit that's covered in this class, and it's exponential and logarithmic functions. And I think it's really unfortunate that I'm not able to do this in a physical class with you guys, because this section is so important. It's so useful in terms of like applications, especially in this middle, like in the middle of a pandemic, right? So a lot of times when I'm teaching this section in person, I have a lot of like, as I'm talking, I think, oh, here's something I want to say, here's something I want to elaborate on, la 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 la. And I'm not quite able to do that when I'm doing videos, because I want to try and keep the videos a little bit short so that you don't feel like you have like 3 hours of lecture to watch, and that's probably pretty boring, honestly. But there's so many things that I need to say about this section. So I'm just gonna spend, I don't know, so this is already a minute long somehow. I'm gonna spend a couple minutes kind of talking about why this section is important, what I want you to be able to take away from this section, and like a preview of what we're gonna do in it. So this is exponential and logarithmic functions, and actually if you've been keeping up with news at all, you probably have heard exponential growth recently, in reference to the pandemic. So all the functions that we've done up to this point have been actually polynomials, right? So x cubed, x squared. Okay, we did an absolute value of x, but they weren't growing too quickly. The slopes aren't too large, basically, right? Linear functions, they just have a constant slope. X squared, x cubed, those things actually have a linear slope, meaning the slope increases just at a linear rate. So these exponential functions are going to be basically unbounded growth. So they're going to grow much quicker than every other function that we've looked at previously, and they're actually the quickest growing functions that we have, classical functions. Now, why this is important, aside from the very obvious, we are living in an exponential growth problem right now. Every semester I always do a problem about a disease that has this many people infected at day 1, and then at day 30 it has this many people, how long until blah blah blah. Like, this is literally a word problem that I give every semester. So aside from that, many things actually are exponential growth. Bacteria colonies are exponential growth. Actually, most populations are exponential growth, because as you have more members of your population, more babies can be born, right? And then the radioactive decay would be exponential. Radioactive decay works by, so the atoms emit decay particles which bounce off of other atoms in the sample, which causes them to decay. So the more you have, the more that are getting emitted, which means the more things that are being hit. So it's exponential as well. And then the other side is going to be the logarithms. Now, logarithms are actually the inverse of exponentials. So logarithms, sometimes students haven't seen logarithms before. Of all the things that are done in this class, logarithms are the thing that I assume not everyone has seen. Everything else is generally covered in a high school and middle school algebra class. You might not remember it being covered, but it generally actually is covered. Logarithms are the one exception to that. You really might not have ever seen logarithms before, and it's usually at the end of an algebra class, so students don't always get to that. So logarithms are going to be the inverse. So instead of growing very, very, very quickly, they're going to grow very, very, very slowly. And the reason that we might want to talk about logarithms is if something grows rapidly, rather than using a regular linear scale, like, 1 square is 1 unit step, we might want to use what's called a logarithmic scale, because it just makes it easier to see the information. So things like pH, decibels, I think, are also logarithmic. Earthquakes are logarithmic, and what that means is 1 unit change. So if you go from a earthquake of, seismic 1 to seismic 2, it's not 1 unit stronger, it's actually 10 times as strong because it's a logarithm. So if you make 2 jumps, if you go from 1 to 3, it's not 3 times as strong, it's actually 100 times, 10 times 10. So logarithms are a way that we can actually work with things that grow very, very rapidly and try and make it like a little more easy to get a handle on our graphs and our data. So we're going to look at graphing exponential equations, solving exponential equations, graphing logarithmic functions, solving logarithmic functions or equations, and then also solving some word problems. Now, the thing that technically is not in the curriculum that I think would be criminal to not talk about with you guys is how exponentials and logarithms are applying to the COVID-19 pandemic. So I do have some extra videos that are going to be put in the Blackboard for you guys. I don't expect you to completely understand everything that he's talking about because I wouldn't say it's too hard, but it's kind of geared for people who already know a little bit about exponentials and logarithms, or maybe are a little bit above like a college algebra level. But I still think that you'll get a lot of good insight from it. Admittedly, when I decided to give you this video as an extra assignment, we were only like 1 week into this pandemic experience, and now I think the video is like a month old, so it's gonna look super outdated, which is kind of crazy, but also goes to show how fast these exponential things happen. So this section I hope you find helpful and interesting, and the most applicable of everything we're going to do. The graphing is important just so that you understand how they look. The solving equations, I mean, we spend a lot of time solving equations, but it's not the equations that I think are so important. It's the actual applications that are important. So on this, I want you to worry more about solving word problems in terms of like what I would want you to take away from the course. Is word problems is much more important. I do put a practice exam up so you guys will know. I'm trying to keep it kind of even, so I can't necessarily hit word problems more on the exam. But if there's going to be one thing I want you to take away from this section, it's how useful and how important exponential, especially, and also logarithmic functions are.